Hey guys, let's take a look at a couple of log equations where we need to rewrite these numbers as smaller numbers so that we can solve. So we can figure out what the variables actually equal. So we're going to look at these two. Let's start with the first one, 36 to the negative 3n equals 216. So I had multiple students this week asking me about logs. It looks like everybody's studying them right now. So I think these are good to include in the Q&A for this week. So I'm going to pull up first a little chart, and this is in your dashboard. You can look for it in the log section or polynomials section. It's in a couple of different places, so you can download it if you want to. But we're looking for these numbers, 36 and 216, just to give us an idea of where we see them. So I see 36 here and 216 here. Those are both powers of 6, right? 6 squared is 36, and 6 cubed, or to the third power, is 216. That just means 6 times 6 times 6 is 216. And that is what I can use. So I'm going to rewrite 36 as 6 squared, but it's already to the negative 3 in power. So I need to keep that up there. And then 216 is the same as 6 cubed. So I'm going to rewrite that as 6 cubed. Okay, so now we know that if our bases are the same, that means the exponents have to be equal to each other also. So I'm just going to kind of get rid of the bases. All I'm interested in now is the exponent part. So let's just write that down and see what that is. So 2 times negative 3n, that's negative 6n. And then I'll divide by negative 6. And 3 over negative 6 reduces to negative 1/2. And so that's it. That's the solution to this equation, is that n equals negative 1/2. So you don't have to have a chart like this. This is just kind of nice because you can see all the, a lot of the numbers in the same place, and you can kind of look for, where the numbers are that you're needing. But, your calculator can give you, if you're like, well, I know 36 is 6 to the second, try 6 to the third, and you'll see really quickly that that works as well for 216. Okay, so let's look at the second one. We have 64 and a 16, and we're thinking about how we can use that. So I'm going to go to the chart again. Let me pull this over. Kind of lose it if I can't see everything there. Okay, so let's see. 64 and 16. Well, I see 64 here, and 16, and 64, and 16, right? So it's in several places. That's kind of interesting by itself. But remember, our goal is to rewrite this so that it's the same base. So I don't want to necessarily use 2. This doesn't go all the way to the 6th power, which is actually 64. So we could use 2. But I see it right here for 4. So 8 I don't want to use, because 8, there's not an 8 to a power that gives me 16, because it's not 8 times 2, it's 8 times 8 times 8 times 8. All right, so I'm going to use the 4, because 4 squared is 16 and 4 cubed is 64. So that's going to work for this one, 4 squared and 4 cubed. Okay, so let's go back to this. And let's rewrite this one. So 64 is 4 cubed, and that's already to the negative 3 in power. And 16 is 4 squared, and that's already to the n power. So times n, or just n there. Okay, bases are the same. That was the point of doing this, was so that we could say, well, that means that the exponents are the same. So we're going to set the exponents equal to each other and solve for n. 2 times n is 2n, so I went ahead and wrote that. 3 times negative 3, that's negative 9n. All right, that looks kind of funny. So remember back to way back in Algebra 1, but these are can be tricky. We're solving for n, so I'm going to subtract 2n. We could add 9n to both sides. It's up to you. It's negative 11n equals, there's nothing left over here. It's just 0. So you'll divide by negative 11 and get n equals 0. So all of that means that n equals 0. So this step right here is kind of tricky. Sometimes people want to like divide by 2. Well, I want you just to notice if you did that, what would happen. So if we divide by 2, or if we divide by negative 9, we've got n equals negative 9n over 2, and we still don't know what n is, right? There's still an n on both sides. So that is not helpful to us. We want to subtract and just have the n's on one side and the numbers on the other. So anyway, all right. I hope that's helpful in terms of rewriting these as we're beginning to look at logarithms and exponentials. See you next time.